this is not something we've done much of. And so before we tackle this problem, which is really tricky because it has a number in here along with an exponent in here, and we get into some different exponent rules. We're going to forget this for just a second, and I'm going to make up a different problem that should be easier, that will guide us into understanding this one, just to refresh our memory, because like I said, we didn't do this very much. So for just a second, let's expand this one. Let's make it y plus 2. Okay? And it's going to be y plus 2 and it's to the 4th power, and the directions will say expand it. Now, there's an old joke with that if we're going to expand it, then it would go like this. That's not a very funny joke. Obviously, it's expanded, but if we really didn't do what we needed to do. Again, this is a shortcut, although it doesn't seem like a shortcut. It's a shortcut to foiling. Otherwise, we would be doing this right here. We'd have y plus 2 times y plus 2 times y plus 2 times y plus 2, and we would foil and distribute and put our like terms together, and we would end up with a 5-term polynomial. Now, how do I know it's a 5-term polynomial? Because of the shortcut. Here we go. 1, 2, 3, 4, 5. Always have, I'm going to write this down because you may want to take notes on your paper here. Always have one more term than your exponent. My exponent is 4, I'm going to have 5 terms. My exponent is 12, I'm going to have 13 terms. We're not going to do them all, but I'm going to have 13 terms. Okay, this coefficient right here is going to be 0, C4. I just lied to you by accident. That's going to be 4C4. Actually, it's going to be the same as, no, it's not, never mind. It's going to be 4C4. This is going to be 4C3. 4 combination 2. 4 combination 1. 4 combination 0. Mr. Reader, I never can remember that, and you barely explained it. Good. Then let's go. Let me explain something to you really quickly, in case you don't know where that comes from. It's always going to be the exponent of the problem, combination, and then count down. The exponent is 4, and then count down. 4, 3, 2, 1, 0. Okay? There are going to be a couple other components to this, and one of them is going to be the fact that the y counts down. So the exponent on the y is going to count down. So it's going to be y to the 4th, y to the 3rd, y to the 2nd, y to the 1st, and for what it matters, y to the 0. Y to the 0, anything to the 0 other than 0. Anything to the 0 power is 1, so we're just going to ignore that. We're going to do something crazy with our 2. The 2 is going to start here and count this way. 4, 3, 2, 1, and then 0. Okay, I'm going to spare you the trouble of typing all this in your calculator, and I'll go ahead and tell you what it is. 4C4 is 1, y to the 4th. Okay, first term is taken care of. 4C3 is 4, y cubed, and we're going to multiply it by 2. And yes, we'll multiply it by 2, but we'll take care of that in a minute. 4C2, that is 6, y squared times 4. 4C1, that is also 4, 1. And then 2 to the 3rd is 8. And then plus 4C0. 4C0 is 1. 1, no y's at all. And I have 2 to the 4th, and that is 16. Okay, let's simplify this a little bit, and then we're going to tackle this problem. Y to the 4th, 4 times 2 is 8. 6 times 4 is 24. That's 32. 1 times 16 is 16. And there we go. Now, I want to ramble here for just a second, if I may. The reason I knew these goes to Pascal's triangle that you saw in middle school, and you probably briefly saw it in my class as well. But basically it's this: 1, 1, 1. Add the numbers above it, bring the ones down on the side. 1 plus 2 is 3, 2 plus 1 is 3, there. And 1, 4, 6, 4, 1. But see, here's the problem. We don't want to go all the way down to 12. And so it's best if we use this method with the combinations. Which, by the way, Sir Isaac Newton explored this back in his day. Sir Isaac Newton did a lot of really cool stuff. While I'm erasing, I'll talk about him. Sir Isaac Newton created calculus, which really helped him explain a lot of the scientific stuff that he was studying, such as optics, which is the nature of light, because people really misunderstood the way light was back in the Middle Ages. They didn't get it at all. And let's see, it says, what is the middle term? What is the middle term? He also dealt with, he was also kind of an astronomer. And so, you know, the nature of gravity and those kinds of things, he really explored that, and he needed calculus to explain it. And so he invented calculus in a way. Well, there was another guy, this is completely free, I'm not going to charge you for this story at all, but there was another man by the name of Gottfried Leibniz. And Gottfried Leibniz also invented calculus, but he did it later than Sir Isaac Newton did. Well, see, Newton did it first, but never published it. And Leibniz did it later and published it, and then there was a huge feud between the two of them about who published what first. And it was basically like high school drama for ridiculously smart people. It was crazy. There we go. What is the middle term? Middle term, where we're going to have 13 terms. We're not going to write them all down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 terms. We want to know the middle term. The middle term would be the 7th one. Is that 7? Yep. This is the one we care about. That's what we care about right there. So I might build a little bit getting to it, but I'm not going to deal with too much with everything else. So here we go. It's going to be exponent C countdown. So 12C12, 12C11, 12C10, 12C9, 8, 7, 6, 12C6. Okay? I'm leaving out the things that I really don't care about. It's just going to help me get to that one because that's all I care about. Okay, in the middle, we're also going to deal with our x. So we have x squared to the 12th. It's getting sloppy, but it's x squared to the 10th. X squared, my word. What comes after 12? 11. What comes before 12? 12, 11, 10. Oops, messed up. 9, 8, 7, 6. Again, x squared to the 6th power. And we also have a 3. Well, let's do it. I'm going to switch colors here just so things don't all run together. So the 3 starts on the other end. 3 to the 12th. 3, 12. 3 to the 11th. 3 to the 10. 3 to the 9. 3 to the 8. 3 to the 7. And then 3 to the 6. Okay, it's really jumbled and you may not even be able to see that, so I'm going to rewrite all that down here and then we'll really fix it. And then we'll be done with this problem. So 12C6. There's one part of it. The other part is x squared to the 6th. And the third part of it is 3 to the 6th. And all that is in one term and it's all multiplied together. So before we even grab a calculator, let's do the easy part first. X squared to the 6th power is x to the... Okay, you probably had 2 guesses. You probably either said 8 or 12. So which one is it? Let me tell you. No, I'm not going to tell you. X squared times 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 x squared. There are 6 x squareds. That means I have 12th power. If it's a power to a power, you multiply. Just saying. Okay, 3 to the 6th power is something I should know off the top of my head, but I don't. 3 to the 6th power is 729. So we're going to multiply it by 729 over here. It's pretty big. 12C6, I do not know that one off the top of my head either. That's why I have a calculator. 924. I'm color-coding everything. 924. Okay, final answer is going to be what you get when you multiply these together. We'll write the final answer in black. 924 times 729 is 673,596 x to the 12th, because those two got multiplied together. There you go. That is the middle term.